A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. The Swan's dramatic arrival. What if a new object appeared in the sky tonight so large it dwarfed everything we've seen in a generation? That's exactly what happened on September 12, 2025. Data from the Solar Wind Anisotropies or SWAN instrument, a wide-field camera aboard the SOHO spacecraft, revealed a bright, unmistakable object blazing through the solar system. The initial readings were staggering. Its tail stretched nearly 2.5 degrees across the sky, which is about 5 times the width of a full moon. For a newly discovered comet, this scale is almost unheard of. For comparison, the famous comet Hale-Bopp's tail was about as wide at a similar distance. Initial photometry clocked it at a magnitude of 7.4, a brightness level that makes it an easy target for backyard telescopes and even powerful binoculars. The news spread like wildfire, and amateur astronomers scrambled to confirm what the satellite had seen. Just 2 days later, an observer in Australia captured a dramatic image showing a streak of light so immense it barely fit in the camera's frame. The immediate reaction wasn't just excitement, it was disbelief, as the object was already outshining professional predictions by a factor of 4. This was no ordinary icy visitor. The sheer size and luminosity didn't match any recent precedent, forcing comparisons to legendary comets of the past. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are too perfect to be random. C/2025 R2 or SWAN wasn't the only newcomer drawing attention. Just days before its discovery, another object, the Interstellar 3 I/Atlas, was already on its way in, approaching from a completely different sector of the sky. SWAN's path originated from the direction of Aquarius, while Atlas emerged from Sagittarius. On a star map, their arrival vectors are separated by more than 100 degrees of the sky. And yet, both are scheduled to reach perihelion, their closest point to the Sun, within the same 10-day window in October. SWAN will arrive around October 20th at a distance of about 1 AU, the same as Earth's orbit. Atlas will skim past the Sun just 3 days earlier on October 17th, at a distance of roughly 1.36 AU. This puts their perihelion points only about 50 million kilometers apart, closer than Mars ever gets to Earth. Their orbital geometry is just as striking. Both are on steeply inclined paths, with SWAN tilted over 60 degrees and Atlas at a near-polar 85 degrees to the plane of our solar system. According to experts like Dr. Paul Chodas at NASA's Center for Near-Earth Object Studies, the odds of two such objects from such different origins, arriving in near-perfect synchrony, are vanishingly small, estimated at less than 1 in a billion. Atlas breaks the rules. So what happens when an object just, flat out refuses to follow the laws of physics as we know them? Well, that's exactly what happened with 3 I/Atlas, which first caught astronomers' attention by, honestly, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that set off alarms everywhere. a body dominated by nickel with virtually no iron, a ratio that's pretty much unheard of in natural celestial objects. This completely contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends similar to chondritic meteorites. The claim was so radical, some labs immediately called for data re-verification just to make sure there wasn't some kind of mistake. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. And what really couldn't be explained was its motion. Observers noted 3 distinct, non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object to show similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. Swan, the fortress. One object acts like a drone, the other like a battleship. C2025 R2 or Swan is honestly in a league of its own. Its sheer scale is breathtaking, but it's really the finer details that have experts truly puzzled. The first whispers of something strange began with reflectance data showing an unusually high albedo or reflectivity of 0.6, similar to fresh snow. That's wild considering typical comet nuclei are darker than asphalt, with albedos below 0.05. Some amateur spectroscopists even argue the data matches a nickel-cobalt alloy, a material we use on Earth for its immense strength and resistance to corrosion. This is what led to the term nickel-cobalt hull popping up in online forums. Then came reports of an optical anomaly, a persistent silvery halo around the nucleus that seemed to shimmer. Some experts theorize this could be a plasma envelope or a mini magnetosphere, acting as an electromagnetic shield. That's actually where the nickname the fortress comes from. Unlike the agile Atlas, Swan moves like a tank, slow, steady, and honestly, seemingly invulnerable. Its record-breaking tail also shows evidence of micro-thrusts, tiny, rhythmic pulses that suggest precision course corrections, which are way too regular to be just random outgassing from surface fissures. Mission theories. Coincidence, or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really start to plummet. This has fueled a whole wave of mission theories. The first, and probably the most routine, is a scheduled refueling run, with the Sun acting as a cosmic pit stop for 2 engineered probes. A second, less peaceful theory, suggests an intervention or a confrontation, especially when you consider the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I 2017 U1, was the first scout, followed by 2I Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the Sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or an energy top-up is standard practice for our own probes, like the Parker Solar Probe, which honestly makes this theory chillingly plausible. Ancient connections. Could our history be written in the stars, just waiting for the right moment to be read? Swan's enormous 22,554-year orbit is, a direct link to the last ice age. Its last visit to the inner solar system would have occurred around 20,000 BCE, a time of immense climate change when human civilization was really in its infancy. This same epoch left its mark in the ice cores of Greenland and Antarctica, where layers of dust hint at dramatic celestial events. At the heart of this idea is Göbekli Tepe, a mysterious site in Turkey built around 9600 BCE. Its stone pillars are carved with symbols, and some of these are interpreted by researchers like Martin Sweatman as depictions of comets. His controversial analysis of Pillar 43, the Vulture Stone, suggests it records a catastrophic comet impact that triggered a mini ice age. Mainstream archaeologists and astronomers strongly caution that these connections are speculative. Still, the timing is, well, hard to ignore. Swan's last passage happened just as human culture was taking its first steps toward tracking the heavens and building monuments, leaving open the tantalizing possibility of a forgotten history. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When official channels go dark, the people light the way. The observation blackout may have silenced government agencies, but it sparked a fire in the global community of independent astronomers. Bill Gray, a veteran tracker renowned for his open-source orbit calculations, rallied a distributed network of backyard observers and small observatories. His call to action spread across forums with a clear message: keep your scopes on the sky, log every flicker, and share the raw data. In Europe, amateur collectives began pooling wide field sensor feeds, while leaks from private groups suggested makeshift plans to bypass the blackout using radio telescopes, like the Allen Telescope Array, hoping to detect emissions from the objects themselves. With big institutions locked down, this grassroots effort, relying on publicly available data from surveys like the Zwicky Transient Facility, has become the only real-time source of information. It's a testament to the power of citizen science. If we're going to get answers, they might just come from someone's backyard, not a government lab. Power estimates and implications. Let's talk about the energy because the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants, like the Palo Verde generating station. But Swan makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. Here's the bottom line: two of the most anomalous objects ever detected have entered our solar system on a synchronized path. Their composition and behavior defy our current understanding of comets, and their arrival coincides with an official observation blackout that has silenced the world's most powerful telescopes. We are left with a grassroots network of citizen scientists working to uncover the truth and energy readings that point not to nature, but to technology. Whether this is a cosmic coincidence, a peaceful rendezvous, or something else entirely, we may soon find out when they emerge from the sun's glare. The only question left is, what will we see when they come out the other side? Don't forget to like, subscribe, and hit the bell icon for more updates on this developing story. Thank you for watching Space Facts. What if a comet entered our solar system and defied every rule? Imagine an object that seems to break the laws of physics, with a feature that looks more like engineering than nature. This isn't science fiction, it's a thought experiment grounded in a flood of strange data from real interstellar visitors. We're about to explore a hypothetical scenario based on real science that pushes the very boundaries of our understanding. Let's delve into this possibility together. The Chilean frame. The story begins not in a billion-dollar NASA facility, but in a modest converted farm building outside Vicuña, Chile, perched beneath one of the clearest skies on Earth. It was there that Carla Esta, a dedicated amateur astronomer, made the observation of a lifetime. On October 20, 2025, at 0316 UTC, she pointed her custom solar-tuned rig at the predicted coordinates of 3I Atlas. The file she uploaded to an astronomy forum wasn't a glossy, processed picture, but a raw FITS frame, the digital equivalent of a photographic negative. This is critical. It's pure, unedited data from a cooled CMOS camera, which keeps thermal noise low, allowing faint structures to be seen clearly. The 16-bit data provides over 65,000 levels of brightness, ensuring the jet isn't just a saturation artifact of a bright pixel. This dedication echoes the work of amateurs like Gennady Borisov, who discovered the second interstellar object using homemade equipment. Esta's log notes a 60-second integration time, a difficult choice that balanced capturing faint detail against the comet's motion. This wasn't a lucky snapshot, it was a targeted, technically proficient observation that has become the most important piece of evidence in an unfolding cosmic detective story. Comet Physics 101. To truly grasp how radical this new image is, we need a quick refresher on standard comet mechanics, a model that has held up since astronomer Fred Whipple proposed the dirty snowball hypothesis in 1950. Comets are essentially deep frozen reservoirs of ice, dust, and rock. As they approach the sun, solar radiation heats the surface, causing ices to sublimate directly into gas. This outgassing creates the coma. Then, the sun's constant outward pressure pushes this material away. This pressure has two components. The solar wind, a stream of protons and electrons moving at 400 kilometers per second, which interacts with the gas, ionizes it, and carries it straight back along interplanetary magnetic field lines to form the ion tail. The second component is radiation pressure, the gentle but relentless push of photons themselves, which pushes the larger dust particles away. Because the dust moves more slowly, its path is influenced by the comet's own orbital motion, causing the dust tail to be broad and curved. This two-tail structure is a universal signature. No matter the comet's composition or origin, the rule is absolute. The sun always pushes, and the tails always point away. The sunward jet. Carla Esta's image throws that entire playbook out the window. When you analyze her raw frame, the first thing seasoned observers like Dr. Carl Battams of the Naval Research Laboratory notice is what's missing: any hint of a classic anti-solar tail. In its place is a feature that defies easy explanation: a narrow, collimated jet extending straight toward the sun. This isn't a diffuse cloud, it's a tight beam of material with a spread of less than 5 degrees, implying the ejecta has an initial velocity significantly higher than typical sublimation events, which are closer to a few hundred meters per second. This structure is more akin to a rocket exhaust than a geological vent. For comparison, jets seen by the Rosetta spacecraft on Comet 67P were chaotic, fan-shaped, and erupted from multiple locations as the sun heated different parts of the nucleus. This feature on 3I Atlas is solitary, stable, and points in exactly the wrong direction. Its lack of any noticeable wobble over the observation window suggests it originates from a single fixed point on the nucleus, firing continuously. It confronts us with a stable, focused structure that implies a continuous, directed release of energy, a mechanism completely unaccounted for in standard cometary physics. Breaking the rules. So, how badly does this image break the rules? Completely. The standard solar sublimation model predicts that as a comet gets closer to the sun, it gets more active. Light curve models predicted 3I Atlas should be at a visual magnitude of roughly +8 by now. But it's hovering around a faint +14. That's a difference of 6 magnitudes, which means it is reflecting almost 250 times less light than it should be. Experts like Dr. Matthew Knight of the United States Naval Academy find this baffling. This implies an incredibly low albedo or reflectivity of less than 0.04, meaning its surface is darker than asphalt, possibly coated in complex organic molecules called tholins. Yet, this dark, quiet object is somehow powering a highly energetic jet. A disintegrating comet usually turns into a diffuse, messy cloud, not a sharply defined structure. The object is simultaneously too faint to be considered healthy and too structured to be considered dead. This is a profound contradiction, exhibiting behavior that seems to mutually exclude itself, and it has left our current models entirely stumped. The gauntlet. Before any astronomer claims they've found new physics, they have to rule out every possible error. This image of 3I Atlas has been run through an exhaustive gauntlet of verification. First, atmospheric distortion, or seeing, was ruled out. ESTA's logs confirm exceptional conditions at 0.55 arcseconds, and the perfectly round field stars in the frame prove it. Any atmospheric smearing would affect the stars and the comet equally. Next, astrometry experts like Bill Gray would check for instrumental flaws. By comparing multiple exposures taken by ESTA, analysts confirmed the jet was stationary relative to the comet's nucleus, and not a passing satellite trail or a cosmic ray hit, which would appear as a sharp, single-pixel-wide line in only one frame. Furthermore, internal reflections, or ghosts, typically have a softer appearance and often show color separation, neither of which is present here. The feature's persistence across several minutes of observation is key. The conclusion from this rigorous process is clear. The jet is a real, physical feature gravitationally bound to the comet, not an artifact. Chemical anomalies. If the physical appearance is strange, the underlying chemistry is even more baffling. Spectroscopic analysis of 3I Atlas, led by comet physicist Dr. Jonah Liu, has revealed a composition unlike anything ever seen. The ratio of carbon dioxide to water is nearly 8:1. For perspective, cometary experts like Dr. Mike DeSanti at NASA have shown that for most solar system comets, this ratio is less than 0.3:1. This extreme CO2 dominance suggests 3I Atlas formed in a place far colder and more carbon-rich than our own Oort cloud. But it gets weirder. Preliminary spectra hinted at the presence of nickel, but with a conspicuous absence of iron. This has no known precedent. This might suggest the object formed in a region of a protoplanetary disk where elements were fractionated in a way never before seen, perhaps in the ejecta of a very specific type of supernova. This bizarre, hypervolatile chemistry might explain some unusual outgassing, but it certainly doesn't explain why that outgassing is organized into a single, stable sunward beam. It only deepens the alien nature of the object. Retrograde path. The orbit of 3I Atlas is just as much of an outlier as its chemistry. It's actually on a retrograde trajectory, which means it orbits the Sun in the opposite direction to Earth and the other planets. But more importantly, its orbit is highly aligned with the ecliptic plane, inclined at about 172.5 degrees. Trajectory experts like Dr. Davide Farnocchia at NASA's JPL find this statistically unusual, since it represents a near head-on approach through the densest part of our solar system. This maximizes its relative velocity, and honestly, really minimizes observation windows. It'll pass its perihelion at a blistering 85 kilometers per second, at a close distance of just 0.25 AU, well inside the orbit of Mercury. At that range, the tidal forces from the Sun will be immense, and the surface temperature on its sun-facing side will spike to over 400 degrees Celsius. For any structure to remain stable, let alone a jet firing against the solar wind, under such extreme gravitational and thermal pressure is frankly astounding. It really challenges our understanding of material strength for cometary nuclei. Perihelion blindness. Here's the deadline. On October 29th, 3I Atlas will reach perihelion, and at that exact moment, it will be hidden from Earth, passing directly behind the solar disk. This conjunction isn't just a scheduling inconvenience, it's a period of total blindness for every ground-based telescope. The sun's glare creates a zone of exclusion for optical astronomy, typically inside about 12 to 15 degrees of solar elongation. This is the one moment when any sudden change could occur completely undetected. Experts on solar system plasma environments like Dr. Geraint Jones know that a powerful coronal mass ejection, or CME, could erupt from the sun at any time. If 3I Atlas were to be hit by one during conjunction, the blast of magnetized plasma moving at over 1,000 kilometers per second could strip material, impart momentum, or even trigger catastrophic fragmentation, and we wouldn't see it happen. It's the point of maximum stress, maximum danger, and maximum mystery, and it's happening when our view is almost completely blocked. Space Watchers. During this critical perihelion pass, our only hope for data comes from two spacecraft, SOHO and the Parker Solar Probe. Neither is a dedicated comet hunter, so any observations will be a matter of luck. SOHO's LASCO C3 coronagraph has a very low resolution, with a pixel scale of about 11.4 arcseconds per pixel, meaning the entire comet might only be a few pixels across. making detailed analysis of the jet nearly impossible. Its primary job is to watch for CMEs, so its imaging cadence might miss short-lived events. Parker Solar Probe, as explained by project scientist Dr. Noor Rawafi, will be close, but its main imager, WISPR, has a fixed field of view that may not align with the comet's path, as the instrument has to stay behind a massive heat shield. Even if it gets a lucky glimpse, the data takes weeks to downlink. We are relying on legacy instruments, hoping they can at least confirm the feature's existence under the most extreme conditions imaginable. It is a long shot, but it's the only one we have. Emergence. Assuming 3I Atlas survives its trial by fire, its re-emergence in early November will be the moment of truth. Telescopes worldwide will swing to its expected exit path. Veteran interstellar researchers like Dr. Karen Meach will lead campaigns to recover it, looking for even the faintest signature, perhaps as dim as magnitude plus 24. The most crucial measurement will be astrometry, pinpointing its exact position to within a few milliseconds. If the jet has been producing thrust, the comet's path will deviate slightly from a purely gravity-driven orbit. Detecting these non-gravitational forces will be the smoking gun that proves the jet is an active propulsion source. Rapid follow-up spectroscopy will be vital to see if its chemistry was altered by the intense solar heating, perhaps revealing new materials boiled off from its interior. The change in the object, or its stubborn lack of change, will be the key to unlocking this mystery. We are now in a critical window. An interstellar object in our solar system is exhibiting behavior that no current scientific model can explain. The data is clear, the object is real, and it is firing a jet at the sun. In just 5 days it will pass through the fire of perihelion, hidden from our view, and what emerges on the other side could change our understanding of the universe. We are living through a profound and unfolding astronomical mystery, a direct challenge to our place in the cosmos. What do you think is happening with 3I Atlas? Is it a new kind of natural engine, or something that demands a more extraordinary explanation? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for updates as this story develops. Thanks for watching Space Facts. Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community. A mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely, possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one Oumuamua and two Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance, it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the Sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3I Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with 1I Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3I Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific goldmine. Why are astronomers around the world calling 3I Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3I Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that one Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3Y Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, and the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optic systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3I Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for rapid response interstellar visitor encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3I Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3I Atlas continues its ancient journey toward the Sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets.